All right. Okay, so today we're doing 6-4, and it's going to be the side splitter and angle bisector part of the unit. So the first thing we're going to look at, we're going to be talking about angle bisectors. But last time, I'm going to make you recall on some information. So last time we learned when we were given a right triangle, so look right here, what makes something a right triangle?
When I was ready.
It has a right angle, which is 90 degrees. Very good. So we were given this right triangle, and we dropped down this altitude, and we knew that when that happened, if we were dropping the altitude down from the right angle, then it would cause us to have two new similar right triangles, correct? Okay, awesome. We had a smaller right triangle and a medium-sized right triangle, and then we have these three similar right triangles. Okay, so very good. Any questions on that stuff that we were doing last time? Okay, so then we also saw that because of this, we could set up our geometric mean. Okay, so the reason I wanted you to recall on what we learned last time is because what we're learning today kind of looks the same, but it's very different. So looking at this, today we're learning the triangle bisector theorem. So looking at this triangle here, notice this is not 90 degrees, okay? So this is not 90 degrees. So when we did drop down from a 90-degree angle, it caused these two new angles to be 90 degrees. Now notice, we're not dropping down from a 90-degree angle, so it is not going to cause these two angles at D to be 90 degrees. So this is very different. But what the triangle bisector theorem says, now this is the shorthand for it, you'll want to write this down, I'm going to just read it from my paper here. So if we have one angle of a triangle that's bisected, so bisected means cut in half, exactly in half. So if we have one angle of a triangle bisected, cut exactly in half, then the angle bisector, so this line right here that's cutting it, the angle bisector of the triangle.
Teachers, pardon the interruption. We need all Son of Thor contestants to please come to the front office at this time.
Did that pertain to any of you? Okay. Okay, so then the angle bisector of the triangle will cut the opposite side of the triangle into two segments. So this does not mean it cuts it into two equal segments. That's not what that means, but it does cut this side into two segments. Okay, so what we find is that if these angles are bisected, cut exactly in half, then we can set up a ratio. So it is cutting this triangle proportionately. So we'll set it up like this. A over D is divided by D over C will be equal to A over B divided by C over B. So it's cutting this proportionately. That doesn't mean it's cutting it exactly in half. Now once again, looking at these angles right here, are they 90 degrees? No, in fact, look at them. One of them will be acute, meaning less than 90 degrees, and one will be obtuse, meaning larger than 90 degrees. So this won't necessarily cut it to be 90 degrees. Now, if we have a right triangle and we're bisecting that angle, we're going to have to use, not this new way, but we're going to have to use the right triangle setup. So do you guys see the difference? Because on the test, you're just going to be given that, and there is a difference. So if it's a right triangle and we bisect it, we've got to go off of our hypotenuse, short legs, we got to go through the whole process. But like this, we're almost thankful because we can just set up our ratio like this, and it's a lot easier. Okay, so do you guys all have this down? Now notice I do have angle ABD is equal to angle DBC, so that's written a little bit different than we're used to seeing. But just look at what I'm saying here. So angle ABD would just be going like this, ABD. So really angle B, right? Angle B, and so then that is equal to DBC, so it's just saying that those angles are equal. Does everybody get that? Are we all good? Okay. Okay, so we can use this triangle bisector theorem to determine missing side lengths, and then we can kind of use it to determine if line segments are parallel as well, but we'll get to that later. So let's do our first example. Okay, so once again, it says, find the missing value. So get this first triangle down. So we have triangle ABC, and then we have it set up like this. Now once again, we would look and see, is this a right triangle? No. So we're going to kind of say phew, because the right triangle ones are a little bit harder. These ones are really easy. We know that this is cutting these triangles, this is cutting this triangle proportionately. So we'll just set up our proportion. So we're going to do 7 over x will be equal to, now if I started with this triangle, I need to stay with this triangle to stay consistent, so 21 over 18. We could have gone the other way though. We could have gone x over 7 will be equal to 18 over 21. We just need to stay consistent. Does that make sense? All right, so let's go ahead and solve for x then. we're gonna cross multiply. Okay, so let's cross multiply. So we're multiplying both sides by 18, but ultimately this one's gonna divide out, so I'm not gonna write it over there. We're gonna multiply both sides by x, but once again, I'm not gonna write it on this side because it will divide out. So let's do 18 times 7. What is 18 times 7? 126. So we have 126 is equal to x times 21, which is just 21x. How do we get x alone at this point? Divide by 21. So we'll divide both sides by 21, and we get x is equal to 6. So x is equal to 6. You guys see how I set that up? You'll need to set it up in this ratio.
So you go from 7 to x, 7 over x, and then 20 to
Right, because it's cutting it proportionately. Yep. So you'll go 7 over x. We started with that triangle, right? It's cutting these sides proportionately. That doesn't mean they're equal, but they're proportionate. So 7 over x will be equal to 21 over 18.
What did we just say about the other one? Like 18 over 21?
Yes. Yep.
It always-
Yeah. All right. Let's do one more. Any other questions before we do another one? Last one, and then I'll set you free to work for a while. Yes.
So would you always be using the numbers in those locations?
Yes.
Okay.
Yep.
Oh, so it always goes like shorty or whatever? Or no, you always go bottom?
Well, if we went top to bottom, it would work out to be the same way as well.
But we always set it like next to each other. What, I'm trying to where does this go?
So like, is there only one way to set this up? Or is it like a lot?
Well, there are multiple ways of setting it up, but the ratio's got to be set up like this. The ratios have got to be set up like this, yes.
Are
Okay.
you recording?
Yes. Okay, let's go forward. Next example here. So looking at this, once again, find the missing side lengths. Now on the test, you're going to have to look and see if this is a right triangle, because if you have a right triangle and you try to do it like this, you're not going to get the right answer. So looking at this, is that a right triangle? No, but our angles are bisected, meaning they're cut exactly in half. Now I'll ask you one more time. Does that mean that this angle is 90 degrees right here? No, it doesn't, right? So these angles are not 90 degrees, okay? But it does cut these triangles, this big triangle, it cuts it proportionately. So let's go ahead and set up our proportions. Now once again, yes, there are many ways to set this up, but the proportions, no. You'll set up the proportions the same way. There's different orders. As long as we stay consistent, we can set it up differently. But I always just do the same thing. Why not just do the same process every time so that we get a little pattern down and we just don't make any errors? So we know, we're kind of saying few. We're kind of glad this isn't right, because our right triangle is a lot harder than this, right? So it's kind of nice. It's kind of a relief. So we're going to set this up. Now we can start with x plus 2, or we can start with x plus 1. As long as we start out one way and we stay consistent. So I'm just going to start out with x plus 2. So I'm saying x plus 2 over x plus 1 will be equal to, that over that, will be equal to 7 over 5.6. Very good. Any questions on why I set it up that way? Yes?
So can you do it like x plus 2 over 7?
No. You need to set up your ratios like this, because it's cutting this triangle proportionately, so that side's proportionate to that side as that side is proportionate to that side. Okay. Alright, so let's go ahead and cross multiply now and solve for x. So we're cross multiplying. So we're multiplying both sides by 5.6, and we're not going to write it on this side because it will divide out. Now hopefully we're way past the point of making the mistake of only multiplying 5.6 through to part of this. We've got to multiply 5.6 through to all of this, so I'm putting it in parentheses. And then we're going to multiply both sides by x plus 1. So x plus 1, but it's going to divide out on this side, so I'm not going to write it. And once again, I'm going to put x plus 1 in parentheses. Okay, so now let's go ahead and double distribute here and keep going so we can solve for x. Alright, so 5.6 times by x is 5.6x, and then we're doing 5.6 times by positive 2. 11 point, so plus 11.2 is equal to, now we're distributing 7 through, 7 times by x, 7x, and then 7 times by positive 1, plus 7. Alright, so we multiplied this out, we've double distributed, now we're just gonna combine like terms, get all of our x's on one side, get all of our numbers on one side, and solve for x. So piece by piece we're solving for x. So I'm going to, now there's other ways of doing this, but I'm gonna bring my 5.6x over to this side. So minus 5.6x to both sides. So I'm going to show all my work on this one. So on the left side here we have 11.2 is equal to, what's 7x's minus 5.6x's? 1.4x's, so 1.4x, and then we still have our plus 7. So piece by piece we're trying to get x along. What's my next step? Subtract 7, what's 11.2 minus 7? So 4.2 is equal to 1.4x's. Now how do we get x alone? Divide by 1.4 at this point. 1.4 divided by 1.4, and what do we get? 4.2 divided by 1.4 is? So 3 is equal to, those divided out, so we have 3 is equal to x. So once again, we need to ask ourselves though, is that our answer, or what were we asked? Every problem could be different. So read the problem. It says find the missing side length. So are we asked to just find x or the missing side length? The missing side length. So let's go ahead back up here. So this side BD, we're plugging in x is equal to 3. So we're going to be doing 3 plus 2. So what is BD? 5. So BD is 5. We just found that side. And we know that x is 3. So we're doing 3 plus 1 for DC. And we get 4. Yes.
When I did it, I added 5.6 to 7.
You wouldn't be able to add 5.6x over to 7 because this is positive, right? To undo positive 5.6x's, we'd be subtracting 5.6x's.
I did minus 7x.
That will work great. You could subtract 7x over this way. Yep.
Yeah.
You'll end up with the same answer if you do all your algebra correctly. All right. Yes. Okay. All right. So now you're going to do problems on the worksheet. You're going to do number 7, number 10, number 12, and number 16. You can do all of those problems. So yeah, we're kind of jumping around for a second, but these are the ones I want you to do right now. And then I'll give you some more examples and we'll finish this up. Now, if you get to a problem that you're not sure about, don't just say, I don't know how to do it. Think about it for a second before you ask me. You can ask me, but I want you to think about it for a second, okay? So, ready, set, work. Okay, so we're going to move on. Now, if you're still feeling, you guys, if you're still feeling a little bit lost, watch the next 2 examples, and you can go back to those problems, and I promise you'll have an easier time, okay? So I want you to just pause, look back up here, start taking notes again, and then I promise with a few more examples, you'll feel a little bit better about those problems. All right, so we are kind of shifting gears a little bit, but they still go together. So I want you to think back. We learned about kind of properties of parallel lines. So we learned how to do this problem. This isn't new to us, but let's quickly go through this because we're going to extend on this idea today. So looking at this triangle here, we know that these lines are parallel from those pointy little arrows. We learned that last time, right? Yeah. Oh, 2 times ago. We know that those 2 lines are parallel because of those pointy arrows there. That's saying that those are parallel. Awesome. So we know that if we have these 2 parallel lines and they intersect the other 2 sides of a triangle, that it's cutting the triangle proportionately, right? Everybody? Yep. Okay. So really, we could set this up many different ways. So we could since it's cutting these sides proportional, we could set it up as 11 over 8 will be equal to x over 9, but that's not the only way, because our similar triangle is the huge triangle and then this small triangle, right? So that's another way of doing it. But why not just take it easy on yourself? We know since it's cutting these sides proportionately, let's go ahead. We know it's cutting the sides proportionately, so let's set up our ratio. So 11 over 8 will be equal to x over 9. It's cutting the sides proportionately. So 11 over 8 will be equal to x over 9 because these parallel lines will be cutting these sides proportionately. So let's go ahead and solve for x now. Let's cross multiply. So once again, you guys, we're cross multiplying, so we're multiplying both sides by 9. I'm not going to write it over here because it's dividing out. We're going to multiply both sides by 8. I'm not going to write it on this side because it divides out. What's 9 times 11? So 99. What's 8 times by x? So it's equal to 8x. How do I solve for x at this point?
Divide by 8.
Divide by 8. Divide by 8. What's 99 divided by 8?
12.4.
So 12.375 will round to the nearest tenth, so 12.4 is equal to x. Okay, so let's see, are we done? Yep, we just solved for x, so x is equal to 12.4. Any questions? Okay, so now we're going to be looking at fancier versions of this. So now think about it, guys. I want you to think about it. Parallel lines, they are continuing forever, right? So we could just extend this out because these parallel lines are really going forever this way. Logan, I need you listening. So these parallel lines could keep going forever this way. And then we know that these lines are not parallel, right? Boom, there's their point of intersection. But we could extend them. So really we just have a fancy looking triangle here. Now these lines could keep going up this way and this way. So this is what we're going to be looking at today, but that's still a triangle, right? These are still parallel lines. They're still cutting these sides proportionately, so it's not going to be any different. So let's look at our next example here.
No, I was just talking about that.
No, it's fine. I'm not mad. I just was telling you because this was important. This will help for the next step. Okay, so now looking at this one. Oh no, this is scary. No, it's not. We really just have a triangle just like we just saw. So looking at this, first of all, notice these three lines are parallel. So parallel lines never intersect. By definition, parallel lines never intersect, right? But look at these two lines right here. Do you see any pointy arrows on those saying that they're not straight lines, like continuing forever, but do we see any parallel line marks? No, so those aren't parallel. So if lines are not parallel, they will intersect. They must intersect. So because they're not parallel, they must intersect. And by the looks of it, it looks like they're kind of intersecting up there, right?
Yes.
Okay, sweet. So do we just have a triangle here? Just like in the last example. Yep, because these lines are parallel, they're cutting these sides proportionately. So now we just have this big triangle and this small triangle, but like I said, the parallel lines cutting the sides proportionately means we can just set up our ratio as normal. So does everybody see how it's the exact same thing we just did?
Yep.
Sweet. So 10 over x will be equal to 12 over 4. Kind of cool, right?
Yeah.
All right, so now cross multiplying, we're going to multiply both sides by 4. Does everybody see how I set up the ratio before I move forward?
Yeah.
Multiply both sides by 4, it'll divide out over here. Multiply both sides by x, it'll divide out over here. So we have 40 is equal to 12x. Now what do I do?
Divide by 12.
Divide by 12. So 40 divided by 12,
3.3
3.3 is equal to x. Sweet.
So
Questions?
How would you do it on one that has like a lot more numbers?
So we're going to do another example. Okay, so let's do another one. Questions before we move on? All right, so let's look at this one. Now, this one's a little ski-wampus, but it's no different. We're given the same information here.
That's a great word.
It is a great word. Okay, so we have these three parallel lines, and we can see that these three lines are parallel, but notice these two lines are not parallel. So what? Thus, they must what?
Intersect.
They must intersect, and by the looks of it, they're going to kind of come up here and intersect, right? That's not super important. I'm just showing you that really we just have an upside down triangle. So let's set up our proportions. Does everybody see this upside down triangle?
Yeah.
Sweet. So we know these parallel lines are cutting the sides proportionately. So now watch carefully. These are the ones that most of you are having issues with. This type of problem when we were dealing with x squared. So let's look at how we're going to set this up. X plus 3 over 2x plus 2. So I'm setting up my proportions. X plus 3 over 2x plus 2 will be equal to, and it's cutting this side proportionately, so 2x plus 2 over 4x minus 2. Now, yikes, this looks like a mess. It is a little bit more involved, but it's not too bad. Let's just get rid of our...
Wouldn't it be on the other side of
That's what we've been doing. 10 over x would be equal to 12 over 4. Yeah, it's okay. Okay, so now we're going to cross multiply to get rid of our fractions. So we're multiplying both sides by 4x minus 2. The reason I'm not writing it on this side is it divides out. Now let's throw these in parentheses. I saw a lot of you making this error. Please do not make this error. We're multiplying all of that with all of that. So put it in parentheses because then we're used to seeing it set up this way. All right, and multiplying both sides by 2x plus 2. So we're multiplying this side by 2x plus 2. but it will divide out over here. Now once again, put it in parentheses. Alright, let's not make the error though, you guys. Let's not make the error that a lot of people make by just saying 2x, multiplying the front terms, and then multiplying the 2's. We can't do that, right? We've got to double distribute. Okay, so let's start over on this left-hand side. 4x times by x, 4x squared, 4x times by 3, plus 12x's, and then we distributed the 4x through. Let's distribute our negative 2 through. Negative 2 times by x, negative 2x, negative 2 times by positive 3, minus 6. Let's go over to the other side. Any questions on that part? So on the other side, we're doing 2x times by 2x, 4x squared. You guys are getting really good at this. 2x times by 2, plus 4x. Continuing, now we've distributed that through. Let's distribute this through. 2 times by 2x, plus 4x's. 2 times by 2, plus 4. Alright, so now let's combine like terms on the left, let's combine like terms on the right, and then we'll keep going. So combining like terms over on the left, we have 4x squared, no other x squareds. 12x's minus 2x's is how many x's? Plus 10x's minus 6. So we've taken care of that side, which is equal to, now on this side, we have 4x squared, plus 4x plus 4x, plus 8x. Awesome, no, you're correct. Plus 8x plus 4. So we just took care of that side combining like terms. We're trying to solve for x, right? So you guys, if we were dealing with x squareds, that would be fine. We would solve, we know how to solve quadratics, right? Quadratic formula, or we could solve by factoring. Okay, so if we end up with a quadratic, we'd be okay. We'd survive because we would do the quadratic formula. But let's see if we even end up with a quadratic. Let's go through this and see if we do. So now we need to combine all like terms. So subtract 4x squared, subtract 4x squared. Now Isaac, we can't just go 4x squared and 4x squared, combine them, right?
Yeah, so you.
So I subtracted. Did that? Yeah. Okay. Awesome. All right. So now 4x squared is gone, right?
Yep.
Oh, look at that. We don't even have to deal with the quadratic on this one. We'd be okay though if we did. So now let's combine our x's. Should we bring 8x over this way or 10 over that way? Yeah, let's bring 8x over. So subtract 8x. Now don't just magically float it over. Actually do the operation you need to do to undo it. So 10x minus 8x is, so we have 2x minus 6 is equal to now 4, right? So do you need me to show all those steps or can I kind of skip?
You can just add.
So we're going to add 6 to both sides, add 6. So then we get 2x is equal to 10. So now to solve for x, our last step will be to divide by 2, x is equal to 5. All right, x is equal to 5. Any questions? Okay. Now once again, there's going to be a bonus problem and it's going to be end up quadratic. You can solve quadratics by the quadratic formula, or if it solves by factoring, you could try that. Okay, moving on. Last example. Yes.
Are we supposed to plug it in for the ones? No, it just says.
Really good question. So such a good question. It depends on the question and what it's asking. So notice this one just says find x, so we did, so we can stop. So if it said find the missing side lengths, we would absolutely plug in 5. So that was a really good question. Okay, last example, then I'll set you free to work. Okay, so stay with me. Now once again, some of you are breaking the forbidden rule and you're not paying attention. So I need you to stop breaking it and look back up here. Last example, and then you'll have the rest of the time to work. So it's worth it for you to just watch my lesson and know how to do it. Here we go. Okay, so looking at this here. Looking at this, we have these 3 parallel lines, and this time we have 3 transversals, or 3 lines that are not parallel, right? So these lines are not parallel. So what do we know about those 3 lines? They must intersect at some point. And it kind of looks like they're going that way, up that way, this is going up that way, and at some point up there, clear up there somewhere, they're going to intersect. But that's really all, I mean, we don't need to know that. I'm just showing you that really we just have some triangles, right? So notice we have this huge triangle, we have this one small triangle, this one small triangle, so really we're just going to look at this piece by piece.
Can't you speak to you any of those?
Yeah, so there's a lot of different ways. Yep, so as long as, so we know that since these lines are parallel, it's cutting these sides proportionately, right? So I'm just going to have us focus on, we have this triangle right here, right? right? We know it's cutting those sides proportionately, so let's set up our proportion to solve for x first. Why not? So it's cutting those sides proportionately, so we're going to be doing 4 over 3x will be equal to what? 2.5x over 7.5. Now I need you to walk me through this. Let's get through this now. So multiply both sides by 7.5, multiply both sides by 3x. So our denominators cancel out. What's 7.5 times by 4? So we have 30 is equal to, now be careful on this side, 2.5x times 3x is, good, 7.5x squared. Awesome. We're trying to solve for x piece by piece. So what should I do next to get x so long? Good, divide by 7.5, divide by 7.5. What's 30 divided by 7.5? 4. So we have 4 is equal to x squared. So now we can just take the square root, right? We couldn't do that though if there was an x over here, right? If there was some sort of x. But this one's nice. We'll just take the square root of both sides. So what is the square root of 4? 2. So 2 is equal to x. Now really though, you guys, really, in all reality, the square root of 4 is plus and minus 2, right?
Yeah.
But the minus 2 in this problem, in this context, wouldn't make sense, right?
Yes.
That'd be a negative side. We're not going to do that. So x is equal to 2. We just found x is equal to 2. Sweet. So x is equal to 2. Now let's solve for y. So there's two different ways of doing this one. Now, once again, we have this triangle, this triangle right here, and we could set up a proportion right here with this side and this side, or we could set up a proportion with this huge triangle with these two sides and these two sides. It doesn't really matter. It'll be the same answer. So do you want to use this triangle or the huge triangle? It doesn't matter. The huge triangle. Okay, so we're actually going to look at the huge triangle. You guys decided?
Doesn't that make it harder?
No, it'll be the same work no matter what. So we know that so we're looking at this side and this side, and we know that since these lines are parallel, it's cutting these sides proportionately. So we're going to do 4 over 3x is equal to 13 over y.
Wait, so you could do like 2.5x over 7.5x?
Yep, and we could have also done 2.5x over 7.5 will be equal to 13 over y, either one. But now, yikes, we have two variables, but did we find x? Yeah, so let's put that in. Good, so we're going to put that in. X is equal to 2, so we have 4 over 3 times by 2, which is 6. So we have 4 over 6 is equal to 13 over y. And now we're solving for y, so we're getting down to the end. Multiply both sides by y, but it divides out over here. Does everybody see what I did there?
Yes.
Would it be the same if you simplified 4 over 6?
Yep, it will be the same answer. And then multiply both sides by 6, so it divides out over here. So we have 4y is equal to 13 times 6, 78. Divide both sides by 4, divide by 4. Y is equal to 19.5. You guys, and I promise I did it in my other class. With this one, we got the same answer. So y is equal to 19.5. We found x and y. Any questions?
Good work.
You guys, it's just a bunch of triangles. Okay, we are all set.